Hello and thanks for watching Go Teachers Maths. I'm going through the Edexcel 2019 higher tier paper. This is paper 1 and I'm going through question 19, which is a question about completing the square for a quadratic. So we can see that what we've been asked to do is take this quadratic expression and put it into the form x minus a squared minus b. So that's the completed square form. And what we can do for that is use a formula. So we can say, if we have a quadratic in this form, x squared minus, plus bx plus c, then we can write it as being x plus b over 2 all squared minus b over 2 and then plus c. So that's a handy formula where we can take any quadratic and we can put it into this completed square form. So in our case, what we've got is x squared minus 6x plus 1. So if we compare coefficients, we can see the value for b is actually negative 6 and the value for c is 1. So we're going to substitute those values into our formula. So we can see we've got x plus, and then it's negative 6 over 2, replacing the b by the negative 6, and then minus, I just realised I missed off a square there we go, that's a square in that formula, so minus negative 6 over 2 all squared, plus the value we had for c, which is 1. So if we tidy that up a little bit, you can see 6 over 2, or negative 6 over 2, is actually negative 3. So we've got x plus negative 3 all squared minus, and again we've got negative 3 in there, so negative 3 squared and then plus 1. So if we tidy that up, we're going to use up the rules of positive and negative signs when they're mixed up together. So we had a plus and a plus, that would give us a positive outcome. Positive and a negative would give us a negative outcome. Negative and a positive would give us a negative outcome again. And negative and a negative gives us a positive outcome. So here we can see we've got a positive and a negative next to each other. So what we do, we can say, well, together they will make a negative according to our rule on this second line here. So we say we've got x minus 3 squared, and then it's minus, and then if we square a negative number, we actually always get a positive outcome. So the bit in the brackets is positive, so we can just say 9. 3 squared being 9. So then plus the 1. So that will give us x minus 3 all squared, and then minus 9 plus 1 will give us minus 8. So comparing with what we was asked to find at the beginning, we can see that a is equal to 3 because it's a minus a and it's a minus 3. So a must be equal to 3. And we can see that minus b, well, we've got minus 8 there. So b must be equal to 8. So we've done it. That's the first part of the question, part 1. So now we're looking at part 2. So hence, write the coordinates of the turning point of this graph. To do this, we're going to use the work that we've previously done in part 1. So we can see we can rewrite the x squared minus 6x plus 1 in the completed square form. So we can actually say, well, y would be equal to x minus 3 squared minus 8. And what we're looking for is the coordinates of the turning point of this graph. So the turning points of this graph are going to be the same as the turning points of this one. Now, what do we mean by coordinates of the turning point? Well, if we've got a graph of y equals x squared, which you're probably very familiar with, y equals x squared would actually look something like this. Okay, that'd be y equals x squared. And the turning point is when it stops going down, as it does here, and then starts to come up. And it's just at this point where we've got the turning point. And the coordinates of that point would be 0, 0. Now, what we actually have is what's called a translation of y equals x squared. This is very similar to y equals x squared, except we've modified the x squared bit, and then we've tagged on a bit at the end. We've tagged on the -8. And so the bit that's in the brackets with the x tells us how far we're actually going to move this graph here, the y equals x squared graph, in the x direction. And we actually translate it by minus whatever the value is there. So we can call it a translation vector. So we can say, well, if it's -3 there, that means we're going to move it actually in the opposite direction. We're going to move it by 3 in the positive x direction. This bit, the second bit here, tells us how far we're going to move it in the y direction. So how far this point here, the minimum, is going to move in a vertical direction. And we can see we're moving, it's a -8, so it actually moves in the same direction as the sign that's there. So it moves in a negative direction in the y. So what that means it would look like is, if I draw the two graphs underneath each other, we can see that it's going to take our original point here, the turning point, it's going to move it by 3 in the x direction, 1, 2, 3, and it's actually going to move it down by 8 in the y direction. So 1, 2, 3, 4, 5, 6, 7, 8, so something like that. And so there we go, that coordinate being 3, that coordinate being 8, and if I draw the graph on there, it will look like that. So a translation means it's going to be exactly the same shape as the original y equals x squared, it's just moved. So it's moved by, as I've just said before, it's moved by 3 in the x direction, it's important to note, taking the opposite sign to the one that we have here. So the sign flips. If it's a positive, it would have gone to negative here. If it's negative, it would have gone to positive. The sign in front of the bit outside the bracket actually stays the same. So we can see that we've ended up with a negative in the y direction. And actually, that is the coordinate also of this point, which is the turning point. So we're going to write that in our little space for the answer. The coordinates of the turning point are 3 minus 8. There we go. I hope that's been helpful to you. If it has, we'd love it if you would like our page and subscribe to our channel. And also for further help, if you want to look at our website, which is bestmathstutors.co.uk. Thanks for watching.